got those ingredients which were mentioned in the list for today's activity? Have you gathered?
Yes, miss.
Okay,
No.
we'll do that. But before that, I want to tell you something, some interesting stories, some interesting facts. So just a minute. Okay, can you all see my screen?
Yes, miss.
Yes, ma'am.
Everyone?
Ma'am, it is
Yes,
only
ma'am.
black. Blank.
Blank.
No, yes. Miss. Yes, ma'am. Now it is visible.
Achha. Okay, so let me know, okay? Because if there is some issue you're facing, then please let me know. Okay, so everyone, good evening and welcome to the Acharya Foundation. This is Science Summer Camp, and we are really excited for this period throughout this section because, as Shogatik also said, this is something that we really enjoy. Apart from our regular classes, here we can explore new things, we can learn about new things, and Angela, this is not even a matter of like tension or something. So don't get tensed. This is going to be a very much interesting experience for all of us. So before getting into the activity, as it was mentioned in the word file, that today we will be performing two activities. But before getting into that, I'd like to tell you all some interesting science facts. Okay. Must be some of these you know, some of these are known to you. I mean, these are new to you. But let us just look into this. So, our first fact of science. First fact is that, is my screen visible? I hope so. Yes.
Yes, ma'am.
Can you see this one? Since childhood, we are playing with so many magnets. I have played a lot with magnets. Have you? And feel free to talk during the class because this is going to be an interactive session. It is not like I'm teaching you something and you are students here. So this is going to be an interactive session. So please feel free to talk.
Yes,
So
ma'am. I played with magnets.
we have played with lots of magnets. Now this is our most powerful magnet in the world till now that we have prepared, we have made. And the name you can see is neodymium magnet. So neodymium, that's a element in the periodic table. I think you are aware of periodic table. Till now we could have
Yes, ma'am.
find out 118 elements. So this one is one of them, and the
Out of
symbol.
92 are natural occurring and 26 are artificial.
Yes, 92 are natural occurring and others are artificial. So this magnet, it is made up of Nd, neodymium, it is Nd, the symbol is. And apart from this, we also add iron with it to like enhance its strength and all, and boron is also added. So from this GIF, you can understand that how much powerful this is. If you place a watch or an apple, the apple can escape because it was lucky because due to its shape and due to its skin also. So it was lucky that time. But otherwise, just look at that wristwatch, what is happening with. So there is so much strong force of attraction that you can see a spark there also. So that this kind of a spark happens there. Even I also got an GIF where a dummy hand was kept there, and you can like make a guess that if you place a hand there, then what is going to happen with the hand. I did not take that image because there might be some restrictions, so I did not get that. But this is very, very dangerous. Now, this is also very much useful for construction, for other industrial work. These are very useful, but we have to deal with it with lots of protection. Okay, so you got to know about a new kind of magnet. Now let us move to the next one. Can we go to the next one? Are you
Yes,
all
miss.
ready? Okay. The next fact is about oxygen. Okay. So oxygen, it's a very familiar gas. Oxygen is everywhere. It is in air. And we know that oxygen is colorless. We always think that oxygen is colorless. But we have to understand that is in the gaseous state. But if we can solidify or liquefy oxygen, then the color is light blue. This is the color of oxygen element. So if now someone asks you what is the color of oxygen, you must ask that person then which state you are talking about. Are you asking about liquid oxygen, solid oxygen, or gaseous oxygen? So when it is gaseous, that time it is colorless. But if you will liquefy or freeze it, then it becomes pale blue or light blue. Okay. Next one. Done, everyone? Can I move to the next slide?
Yes, miss.
Okay. Acha. I hope Anushmita, Oishik, Aditi, you are all there. Okay. Chalo. Next fact is about helium. See, we all know that if we will keep any liquid in any container, then due to gravity, definitely suppose we are like shaking the liquid, so after a certain time, it should be stable. And it cannot happen that the liquid will creep up or something. There will be spillage or something. It doesn't happen. But that thing happens with helium. In the right hand side image, you can see if you will take some helium to the top of this container, and then after a certain time you can see the spillage. It looks like the helium is going against gravity, so it can actually climb up the wall of the container. That is why the heading is written so it can actually work, it can actually rise against gravity. Why? Because helium, uh, do you all know about noble gas?
Yes, miss.
Right? So what is the formula and symbol for helium?
Ag.
Ma'am, H.
H. Very good. So let us, can anyone tell me what is the symbol of hydrogen?
H.
H.
And what is the formula of hydrogen gas?
Ma'am, H2.
H2.
H2. But what about helium? Helium element is also represented by He, and helium gas, that is also represented by He. So helium is a monoatomic gas. So that is why it has very strong force of attraction, like the cohesive force. It has very strong cohesive force. And also it is known as super liquid because it can actually, you can say it can combat that gravitational force that it will creep up. Okay. So helium is known as superfluid. You must be aware of fluid because liquids and gases, these are known as fluid. So superfluid is helium. Okay. Now the next one. Okay. Very common question. Which metal is used in clinical thermometer? Who gonna tell me the answer?
Mercury.
Mercury.
Ma'am, Mercury.
Yes, very common question. Right? The ma'am has asked us a very, very easy question. Since class 6, we are studying this one. Okay, so why can we use mercury in thermometer? What are the reasons?
Ma'am, because it is when it melts when it is in room temperature. Ma'am, and it can
Right,
detect the temperature very quickly.
As it can expand on temperature.
right. So if we will
It can
just,
actually expand evenly on temperature provided. As such,
very good,
it can be used on a standard unit.
very good. And any other reason?
And because it has a lot of cohesive force but not adhesive force, so it does not stick to the walls of the thermometer.
Very good. And one more reason. I have got so many reasons, and I'm really like really happy to get these answers. And anything else? Okay. So I have got mostly all the answers. Last one can be, it is a very bright metal. So suppose we are taking something which is dull in the thermometer, then we will not be able to observe it because it is shiny. So we can also see it. We can observe it. So that is why till now, mercury is very popular to be used in clinical thermometer. But now we are thinking about gallium. The metal we have taken in the right side in our hand, I mean, not in our hand, in someone's hand, that is gallium. Gallium, it is represented with Ga. It's a heavy metal. And it is, if you'll consider 25 degrees Celsius as room temperature, so at that temperature, it is solid. But around 29.7 or 30 degrees Celsius, it is liquid. So that means if you'll take that on your palm, what is the body temperature of human being? Normally it is 37 degrees Celsius, right? So at that temperature, it melts. So whenever you will keep that gallium in a container, it will be solid if the temperature is below 29. And if you take that in your palm, on your palm, it will be liquefied. But we know that mostly in most of the regions, the temperature, the room temperature is not at all 25 degrees. So now people are thinking of using gallium in thermometer because the reason is mercury is not environment friendly. This is not good. This is a poisonous metal. This is toxin. So that is the reason we are now thinking of gallium. In fact, you know that while traveling through airplane, we are not allowed to carry mercury thermometer.
Yes, ma'am. Ma'am, because means mercury can make damage to the floor of the aeroplane if the thermometer breaks.
Why?
Breaks.
How?
Means,
Ma'am,
but it can also be said that gallium has the same kind of problems because gallium gallium forms quick compounds with other metals and makes them really brittle. So it is actually very dangerous to carry metal gallium near mechanical objects or electrical devices.
Right. So you're correct in that way. Actually, what happens, both mercury as well as gallium, they react with aluminium very fast. And most of the parts of an airplane is made up of aluminium because it's very light and it can make so many alloys which are very light. And we want to keep that airplane fly in the air, so it should supposed to be very light. So that is why in that aspect, both the metals are uh, equally, I can say, or more like uh, both of them are not good as a to be carried in airplane. But apart from that airplane problem, other than this, gallium is better choice over mercury. So that is why now we are thinking to use gallium. Okay, so these were the 4 facts. After that, now we will start our activity. So I think most of you are much more interested for the activity. Right? So,
yes,
yeah,
ma'am.
ma'am has again come and ma'am has started teaching. We thought that there should be a summer camp and ma'am has started teaching. Okay. No, not at all. This was just an introduction. Now we will get to our activity because I was also wanting you to be like acclimatized with this class and all. So today we will be performing 2 activities. Number 1, thirsty glass, and number 2, trap water. Okay. So the first one is going to be thirsty glass, and these are the required materials for thirsty glass. So what we need, a plate or tray, any kind of a plate or tray, shallow, because we need to take some water. Then transparent glass, one transparent glass should be there. Water, normal tap water. Candle, preferably a shorter one. Matchbox, lighter, anything you can take, or any liquid color. Food color, you can take, written as food color, but food color does not give a very bright color, vibrant color. So that is why it is better to take Alta or Ujala. And these are also easily available at home. Right? তো এটা কার কার আছে? How many of you could gather these things? Can you please tell me? Because I want all of you to gather this thing, then we can start performing this activity together.
No, ma'am, I can't gather it.
Okay, Shobhatik, you have not gathered. Then others, Priyam, Shonak, Angela, anyone?
Yes, I have gathered.
You have gathered?
Miss,
Okay.
I could also gather.
You could also gather. Very good. So can you please all just bring these things together and can you show me? Because till then I also need like 1 minute to arrange these things. Okay, I'm stopping this presentation because then you will be able to see it properly. And everyone, this is an activity class. This is a summer camp class. So this is my request to Oishik, Anushmita, Priyam, Shonak, everyone. Please turn on your video.
Yes, Miss, I'm turning on, but there are some problems with my internet, so I'm trying.
Okay. Okay, just a minute. I'm just turning off my video for a fraction of second. Okay, fraction of second, not possible, for a minute. Is my screen visible, everyone?
Yes, ma'am.
Okay, like just you have to say these things and you can then do it. Acha, Rituparna ma'am, is it properly visible, ma'am? কেউ যদি দেখতে না পাও, then please let me know. Okay, so for first experiment, what we need to do is that I have placed this candle here. If you have taken like a candle with wider end, then you can simply place it over the plate. Otherwise, you have to fix this like that. Can you see? Okay. Acha. Then what we will do, I'm now taking some water in the glass. Not very much. Like half glass I'm taking. Now I will add some alta in this water just to make it visible. Okay, understand this has no relation with this with the science. Just to make this visible, I'm adding this color. Okay, that's it. Now I will just add it. Okay, now just add some water in your plate. Can you all show me? Because I also want to see you doing the things. You can just Flip your camera. You can hold it in your hand and you can show me. Yes, Priyam. Very good. Okay. I can see Angela is also doing. So Angela, you can also show me. Okay. Now just add this water in the plate. Okay. In my plate, there are some plates still now, so I can add some more water in it. Then, can you see? Think so. Okay, let me just show you properly. Can you see, everyone? Okay, now
Yes.
what I have to do?
Miss, is this good enough?
You can pour some extra water, Shona. Add
Okay,
some
miss.
little bit of water. Okay, this is why I'm saying that show it to me. Then I can check. Angela, I think you're setting. Can you just show me, Angela?
Yes, Mrs. Vitamin.
Okay, take your time. And Shogati, what happened? You could not gather some water and glass.
Ma'am, actually there is no candle available.
There is no candle available?
No, ma'am.
Okay.
Ma'am, I'm just
Now,
saying all the experiments and then I will do.
sorry.
Ma'am, I will see all the experiments, then I will do it.
Okay, you can definitely do that. But if we'd have done this together, then it would be a different level of fun. That is why I'm saying. Okay, now what will I do? I will lit this candle. I'll just light this candle. Okay. So I hope Angela and Priyam, Anushmita, Shaunak, all of you are doing it. Yes, Anushmita, I can see it. Anushmita, keep your video like that. Okay. Acha, Angela and Priyam, I'm waiting for you. Let me also light my candle. It looks good, right? Ayush, Anushmita, only two of us are showing the candles. Good. Acha, then what we have to do? Okay, just a minute. Priyam, acha, Priyam, do it. Then we will start.
Yes, miss. Is this good enough?
Yes, shown off so many colorful things. Wow. In fact, just a minute. I can also hold my camera like this. Just a minute. Okay, now it's fine, right? Okay, are we all ready? Angela, Priyam, Anushmita, because this reaction, yes, Angela, I can see. Angela, can you take some more water?
Okay, Miss.
Okay, this reaction, this experiment is going to be very fast. So everyone just observe it. This is going to happen very fast. So now I'm going to cover this candle with this glass, definitely by inverting it. Okay, acha. Anushmita, I can see your candle is it is a bit like the size is. Can you just cover the candle with the glass?
Yes, miss.
Okay, okay, then it's perfectly fine. Now I'm just covering it and observe what will happen. Okay, have you all seen? Now do the same thing, everyone. Okay, I can see Angela, Shonak, Anushmita. Okay, I can see 3 of you. So I think what happened here? What happened?
Yes,
Can
I
anyone
think
just tell me
because
what
of
happened?
the reaction of carbon with oxygen,
Yes.
the overall mass inside and pressure inside reduced, which caused the
Okay.
water to go up.
Okay, that is an explanation. I'm asking about observation. What was your observation?
The water in the glass went up
Hmm.
and the candle went out.
The candle went out and the level of water rises up. So this was our observation. Now there will be explanation and shown off. Very good. You are going in a right way. Now let us explain. Let us try to know some in a better way. Okay. So can we now get back to our slide?
Yes, ma'am.
Okay. Shaugatik, you have not done it. I'm very upset with you.
Okay,
Don't
ma'am.
smile.
And do it.
What?
Ma'am, I will gather the things and do it.
Okay. Acha, just for a fun. Okay, now just give me a minute and then I will come to the explanation. Okay, I'm not like throwing away this water because I'm going to use the same water for the next experiment because we all know we need to save water, right? So that is why I have just poured it. You can also do the same.
Miss, is this okay?
Priyam, who is asking this? Priyam. Who asked me? I could not understand. If Priyam was asking me, then yes, it was okay. It was fine. Not okay. It was great. Acha. Chalo, next structure. Just a minute there. Can you all see my screen now?
Yes, miss. Chana.
Okay. So this was our experiment. This is a very simple experiment. You will find it everywhere and it's a very simple experiment. But today you will be surprised to know this simple experiment was performed to for a very popular experiment, popular discovery, or you can say like we will get to know about it. Let me just present the screen. So what happens here, because I think Shona was saying that the mass gets reduced. It is not about the mass exactly, Shona, rather
Miss,
something else.
I can't hear your voice clearly.
Okay, is my voice clear? Can anyone just give me confirmation?
Yeah, your voice is clear, ma'am.
It is
I think
low.
it was Priyam. Hello, Priyam. Hello, Priyam. Priyam চলো কি এটা?
Yes,
Yes,
miss.
sir.
প্রিয়ম তুমি একটা কাজ করবে, ফটটা ডিসকানেক্ট করে আবার রিজয়েন করে নাও, দেখবে ক্লিয়ারিটি চলে আসবে ভয়েসে।
Okay, miss.
সঙ্গে সঙ্গে डिस्कनेक्ट करो, रिजॉइन करो, मैम इतनी तपास स्टार्ट कर दे. Okay, ma'am. So we can just wait for 30-40 seconds, correct? Okay,
Yes,
who
sir.
else are there right now? এখন অনেকজন রয়েছে. Okay, Angelina, Anushmita, Shogotik. Shogotik is back. How are you, dear?
Fine, sir.
আরে বাবা, এ তো একদম অর্ধেক হয়ে গেছে চেহারা. হ্যাঁ?
হ্যাঁ, sir.
Oh my goodness. Shonak is also there. I think all of you are switching on your videos, correct? তোমরা ভিডিও অন অফ করে বসে আছো, এত সুন্দর সুন্দর সব মিষ্টি মিষ্টি চেহারা বাচ্চাদের, ভিডিও অফ করে বসে আছো. আমার তো প্রথম এক্সপেরিমেন্টটা এন্ডের দিকে দেখলাম, দারুণ ছিল. ম্যাম ইজ ডুইং সাম ম্যাজিক্স. Okay, let's see whether he has joined or not. Priyam, have you joined, Priyam? Hello, Priyam. জয়েন করেছো? ঠিক আছে, যার টাওয়ারের একটু ইস্যু রয়েছে তারা ভিডিও অন করো না. ওকে, তাহলে আরো প্রবলেম হবে. ম্যাম, ওভার টু ইউ, ম্যাম.
Okay, thank you, sir. So this is written as a magic or science. So definitely this is not a magic, but yes, if you can perform any scientific activity in a magical way, then it turns to be a magic. So what happens there, since class 6, maybe we are studying about matter, intermolecular space, intermolecular force of attraction, kinetic energy, different concepts are there. So what happens when you are lighting a candle is mainly a hydrocarbon compound that is made up of carbon and hydrogen. Now, when carbon reacts with oxygen, because we all know that combustion is basically happens due to oxygen. So when carbon reacts with oxygen, it will produce carbon dioxide, right? And what is the property of carbon dioxide? It is a very good extinguisher. So that will also extinguish the flame of the candle, that will extinguish it. And also, this candle, it is consuming the oxygen present in that space because we are inverting a glass over it. So the overall oxygen that was present inside the glass is being consumed by the candle. So after a certain time, due to the production of carbon dioxide, that itself is an extinguisher. And number two, due to the shortage of oxygen, the flame is being it is being extinguished. But why the level of water is rising? Why? The reason is that you can see some red dots there. So that represents the molecules which are present in that glass. So you can consider that as oxygen, carbon dioxide. Okay, let us consider about the products. I think all of you are now in class 8. So you know what are reactants, what are products. So in this reaction, the products are going to be carbon dioxide and water vapor. Okay, these things are being produced when we are lighting any candle. So these gases, they have very high energy when they are hot, because kinetic energy is something that increases with increasing temperature. So initially the air was hot inside the glass in our case. So all the molecules were having very high kinetic energy. And can anyone tell me which phenomena is responsible for kinetic energy? Anyone?
Yes, ma'am.
Yes, I was asking that a phenomena that is related to kinetic energy. Phenomena means a thing in our daily life, because you must have observed that every energy that is associated with a physical parameter. For example, sound energy. The energy is sound energy. Because of that, we can hear. Because of light energy, we can see something. Because of heat energy, we can feel the temperature. So in the same way, kinetic energy is something, because of that, any substance can get motion, movement. So if we are moving, that means we are possessing kinetic energy. So here, in the first case, when the air was hot, these molecules were having very high amount of kinetic energy and they were moving here and there. This has been shown by this arrow. So they are occupying this space. Now what happens when the candle is blown off, not blown off, when it is like put off, at that time the air is getting colder. So all the molecules are not getting enough kinetic energy to move. So they are now coming back. They are now being like they are now contracting. They're coming down. So due to that reason, in the upper portion of the glass, a partial vacuum is being created. Vacuum means I don't say that's a vacuum. Rather, I will say that due to this reason, the pressure inside the glass is being reduced. And air always travels from higher pressure zone to lower pressure zone, like the thing we can see in our cyclone also. At that time, the air travels from higher to lower pressure zone. But in our case, we have already kept some water. So that is creating, that is blocking the surface of the glass. Then how can air enter into the glass from higher pressure to lower pressure? Because now in our scenario, the outer pressure, that is the atmospheric pressure, is higher than the pressure inside the glass. So now that pressure, that air is pushing water to get inside the glass against gravity. So this is the reason why the level of water is rising inside the glass. Okay, I think Shaunak was saying about atmospheric pressure, the pressure difference. Very good, Shaunak. But am I clear to others?
Yes, ma'am.
Understood this concept? Anyone? I will not ask question. Okay, don't, because I used to get frightened in school. Like if Miss asked me that, have you understood? And I'll say, yes, ma'am. Then she's going to ask me, okay, then tell me the next question. Tell me the answer. So I'm not going to ask, but I'm asking that, have you understood this concept?
Yes, ma'am.
Okay. Now the interesting fact is that you must be feeling that this is such an easy example, easy experiment. But this experiment was done by Torricelli. Torricelli is barometer. Barometer is an instrument to measure atmospheric pressure. Okay, so Torricelli did that experiment with mercury. You must have heard that atmospheric pressure means 76 centimeter of mercury. So what is that 76 centimeter? Centimeter, that's a unit for length, height, length, that kind of thing. So basically, in case of Torricelli, because of atmospheric pressure, the mercury was rising to the level of 76 centimeter in the tube that he's holding in his hand. So that is also happening due to atmospheric pressure, because at that level, the outer pressure and the pressure inside, that is being balanced. Okay, so the experiment is very simple, but the knowledge behind that is very complex and very important. Okay, done. So this was our first experiment. Now can we go to the next one? Are you all ready?
Yes, Miss.
Yes, ma'am.
So for the next one, that is trap water. We have to trap some water. For that, we need to take some one transparent glass, the same glass that you have used earlier. You can use that. Tap water, same tap water, a cardboard or flat lid to cover the glass, and a sieve. Okay, these are the 4 things. Now, okay, let us do the experiment first, and then there is a very small explanation. I will say that. Okay, so can I just just give me 2 minutes for the setup, and then I'll come back. Until then, how many of you can gather these things so that you can also perform it?
Yes,
Priyam,
I have
Angela,
gathered.
Shaunak, okay, great. Priyam, Angela, Anushmita.
Yes, miss. I got it.
Okay, chalo, tomra niye now, and also allow me a break. Not a break, just give me 2 minutes. Okay, so I'm back with my all my ingredients. Acha. To be on a safe side, I have just taken this container so that if there is any kind of spillage of water, uh, we can manage it. Okay, so it is a recommendation. You can also take any container so that there is no spillage over the floor or over you. And just like the previous one, I'd request Angela, Priyam, Shonak, everyone to turn on their video. Anushmita also, Aditi was there. Yes.
No.
Okay, I'd request everyone to show their, to turn on their video. Okay. So Shonak, can you please gather any kind of container? So if there is any spillage, we can be on a safe side. Okay, so this is a very simple experiment we are going to perform. A sieve is there. I have taken the same water. Okay, this much. Don't take so much water. I have taken like half of the glass, and then I've taken this glass lid. Any of the glass lid, or if you have a cardboard, you can also take that. No issue. Now, what will we do? First of all, I'm just covering this glass with this lid. Okay. Are you all doing it?
Yes, miss.
But
Yes,
why
miss.
is your videos off? What happened, Shonok and Angela? Last time you did so well.
Miss, I don't have a tripod, so I cannot put it to a fixed place and I have to hold it by my hand actually.
Okay. Okay, I understand. Okay. Chalo, tumne dekho tali hobe. So let us just take this. Okay, now I'm going to flip it. So like this, I have flipped it. And after certain time, I will just remove my hand. So you can see the glass, the water, everything is there with the lid. Okay. So this is the first step of this reaction. Shonag, are you saying anything?
No, miss.
Okay. Next step is going to be, have you done this? Okay. The next one is going to be, I'm now going to do the same experiment with the sieve. This time I'm not going to cover it with it. Rather, I'll cover it with the sieve. And then you can also use your hand. But in my case, your hand will also not be sufficient to cover the entire glass. So in that case, I'm just using this one to cover it. Okay. Because the size of my hand is not enough. That is the reason. You can also use your hand. This time I'm going to flip it again. Okay, flip this, hold it for some time, and then gradually remove your lid. And you can see still the water is there. It is not falling. Okay, I'm just trying to take my phone because if there is some just a minute, I'm trying to show you. Just a minute. Can you see this? I hope so. The water is still there, but it is not falling.
Yes, ma'am.
Okay, just a minute. Fine, I'm just removing it. Done. So this was our experiment. Now there is a very good explanation of this one. Just give me a minute. Chogatik, I can remember Diptakni was doing this and she was very excited while doing it.
Yes, ma'am. I have also seen it. And she has.
Oh, that time you are sitting beside her.
No, ma'am. I was not sitting beside her. I was just sleeping in another room. And then she just screamed loudly. And then I came. What happened?
Acha. Yes, Angela, I can see it. The water is not spilling out, right? Okay, great. Shona, Priyam, Anushmita, anyone else?
Yes, I had done the experiment, but I disposed of the water before I could show you.
Okay, never mind. Acha. Anyone else? You can ask to your parents for help if they can hold the camera just for like 1 minute. Then you will be able to show it.
Yes, I don't have any seat.
Sorry, Priyam.
I don't have any seat.
Oh, acha, you don't have any see, but you could have done the first part, like just
Yes,
flipping.
I have done the first part, but I can't do the second part.
Okay. Second part, if you can gather a tea later, you can do that. You can also even try with the tea strainer that we use on daily purpose. You can also use that, but what happens with that if like if it is very much oval or curvy, then there is a chance of spillage of water. The more flat it will be, the more easy, I mean more smooth the experiment will be. Now let us just get back to our explanation quickly. Yes, just a minute, dear. Who was showing? Was anyone presenting something? Acha. Chalo. What is the logic behind this? Can you all see my screen?
Yes, ma'am.
Okay. So what is happening there? Inside the glass, there is water. So water has some, there is gravitation. So we know that if we will normally invert any glass filled with water, so there will be spillage. It will go out, definitely, because of gravity. But in this case, the atmospheric pressure is actually balancing it. And due to the reason, the water is being trapped inside the glass. It is not falling. So that
Means
is
it is also because of the water not being able to go out and the air not being able to go in, there is a state of pseudo vacuum that is stopping the
yes,
water from coming out.
pseudo vacuum. That means the surface of the level. I mean, why we are using here this cardboard or the glass cover? Just to make that space vacuum, because mostly if you'll take a normal container or something, then what will happen, there will be no how can I say, there will be no seal or something, no blockage. But in this case we can actually seal that that point where the glass meets the cardboard, that layer we can seal it, so the air actually cannot pass through from that point. So that is why there is a partial vacuum also. And in fact, if you take a filled glass also, then also you can do it. Okay. So in this, from this experiment, we can make a guess that we are actually here with so much pressure, but we cannot face it. We cannot feel it due to our blood pressure. but actually there is so much atmospheric pressure. I am sure that all of you must be facing, yeah, I mean, must be feeling a pressure kind of thing in your hand when you are holding that glass.
Mhm.
You're experiencing that.
Yes, miss.
So that was that upthrust. Okay, because the pressure working per unit volume, that is force. Weight is also a force, and here also there is an upward force. That is the upthrust that we see. So these are actually counterbalancing each other. That is why we were facing this, we are feeling that pressure in our hand. So this is the first explanation. But in the second explanation, we took a sieve. Sieve has these pores or holes, but still the water is not going out. One reason is that because the water is creating a layer there. We can use our cardboard, or we can simply use the water without using anything. So why does this happen? Because of the surface tension of water. Water can form a very strong hydrogen bonding. Hydrogen and between hydrogen and oxygen, there will be some hydrogen bonding that you will learn in chemical bonding chapter in class 8. In class 9, you will read about it. So because of that thing, water has very strong cohesive force due to that hydrogen bonding. That is why the surface tension is there, and it looks like a blanket. It looks like a sheet of a bed sheet kind of thing that is spread like this. So because of that thing, due to the pores, and even there is a pore, the water is not going away. It is not spilling out. So that is the overall reason. Okay. Now this was, I think, up to this we have, yes. Does anyone have any question till now?
No, ma'am.
No question? Angela, are you still afraid?
So, Miss,
No? Okay. So I just want to know, have you enjoyed this class?
Yes, ma'am. Very
yes,
much.
Yes, miss, very much.
Yes.
Thank you so much, everyone. Chalo, we hope to meet you all again. For today, good night. Take care. Bye.
Bye, ma'am. Good night.
Bye, miss.
Bye.
I'm
Bye. Ma'am, thank you. Okay. Okay, dear. I'm ending this class here. Thank you, everyone. Thank you, ma'am.